Hi everyone, my name is Esin Ergen. I will present construction progress visualization for varied stages of the individual elements with BIM. In this study, we identified a practical problem that is experienced by the practitioners, and we developed a simple solution to overcome this problem. This was the I co-advised a master's student, Daniel Kazado, with Dr. Miroslava Kavgic, and this was his master's thesis. Okay, so what was the problem that we have observed? 4D scheduling is used in the construction industry for the last decade to visualize the progress of construction activities, but the limitation of 4D is it's based on schedules, and the schedules have a limited number of manageable activities. So the activities represent a group of components. For example, the production of columns in one floor or painting of the walls at a specific zone or so. First of all, the components are grouped, so you don't see the progress on individual components. And then the second problem is you cannot see different phases of the project or different statuses of the activities. For example, for MEP components, you might want to see which ones are inspected, which ones are tested, commissioned, or which ones are delivered to the site. But usually we don't have, we cannot go to this level of detail when we have schedules and 4D models to track the progress at site. In large-scale projects, this might be more difficult, because if you want to track the statuses of the activities and of the components and the phases in the project, then you end up having excessive number of activities. Do we really need this level of detail, especially in complex projects, to have to be able to make proactive decisions? You need to at least track the critical building elements at this level of detail, because in some cases, to be able to install a component, you need to make sure that the predecessor of this component is installed or tested or commissioned. This was also highlighted by a previous study saying that the interaction between data at different levels of detail is one of the needs of progress monitoring. So the aim of this study was to present an element-based tracking method for visualization of the actual progress of each element to the lowest level of detail in the model. We performed a case study at a data center building that is under construction. We selected this building because data centers have complex MEP systems that should operate 24 hours and 7 days a week. The MEP services are tested according to the international standards, and the installation of some components, in order to install some components, you need to make sure that some other components are tested or commissioned, so that you can start the other ones. The total construction area of this data center was about 76,000 square meters, and we selected a sample room with a total area of 538 square meters. In this room, in addition to structural and architectural elements, there were about 2,000 MEP elements, including cable trays, bus bar systems, electrical equipment, sprinklers, and ductwork. When we look at the existing schedule and progress monitoring method, we see that the schedule has about 2,000 activities and about 132,000 model elements. The schedule had contractual, design, and construction activities. And the construction phase included only the installation activities, so there is no tracking of the other statuses like installation or, the testing or commissioning of the components. The building elements in the schedule was grouped based on floor system or zones to track their installations. And the progress data is collected using 2D drawings, the daily reports, site reports, and laser scanning. But the statuses of the components were tracked using handwritten daily reports. Of course, because the status data is in the handwritten daily reports, it's not transferred to the schedule and it's not transferred to the 4D model of the project. So what we did was we developed an add-in for an element-based status tracking method. We used Visual Studio 2015 to represent the statuses in Autodesk Navisworks Manage 2018. We selected Navisworks because it's compatible with different software packages and it doesn't allow users to make any model revisions. We defined the parameters for the elements using this tool, and currently if there are parameters that are defined in Navisworks, you need to enter them one by one if the statuses are different. So what we did was you could select multiple elements and enter the statuses at once. So the four main statuses that we represented for the MEP elements were planned, installed, tested, and inspected. The planned ones are shown with gray color, and the installed ones are in green. The tested ones are in blue, and the inspected ones are in red. You can also include other types of statuses such as ordered, shipped, received, or critical components. We visualized the progress over 6 months, and there were about 263,000 component statuses to be tracked in the schedule. So to conclude, in this study, we identified that visualization of the 4D process is limited with the activities defined in the schedule, and sometimes there is a need for tracking different statuses of elements, especially for MEP components. An element-based tracking method for visualization of the actual statuses were proposed, and a case study was performed at a complex data center building. The future work includes integration the schedule with this progress data and updating this schedule based on this progress data. Thank you. Any questions?
Thank you.